So Dyad kind of combines a lot of, it's a dyad, right? It's a dyad of many things. It brings engineers and software engineers together. It brings math and physics together. It brings data and model-based design together. So we felt like this is an appropriate name for this product, is that it's a dyad. It's bringing two different cultures together. It's accelerating a lot of critical industries. We spoke about a lot of these aerospace, automotive, high-tech industries. AI is everywhere. For those of you who are not familiar with engineering product design, this is the world of product design, right? You have requirements on the left-hand side, you have verification, validation on the right-hand side, and then your digital twins in operation. The top parts of this V cycle are actually modeled as ODEs, and then as you kind of get into the details, you get into DAEs, and then as you actually start doing component-level design, you get PDEs. And while the PDE world actually has a lot of amazing software available from a lot of industrial vendors, the ODEs and DAE space is actually fairly light, and it would probably come as no surprise to you that Chris and I decided to focus on this world as we go forward. And we have over 50 talks at JuliaCon over the next 3 days that will touch upon the underlying mathematics, the underlying physics, the software engineering. How does Julia make small binaries? How to constrain the size of the system image? Every single thing that we all grapple with here is actually coming together into actually building real products for physical products, right? When you talk to engineers, they're like, Julia's cool, but it's all code. I can't work with code, right? Engineers are not software people. You need to have a GUI. You need to sort of have an intuitive grounding in the kinds of models you're building. This is the fundamental sort of push and pull, right? That we want something that's a first-class coding environment. You want Cursor, you want Claude Code, you want the 32 terminals that Chris is running, to design every component of your airplane while he's sleeping. But you also need to be able to see what was produced and verify it and validate it and do all of that. And Dyad is our answer to all of that. So
here's a view of Dyad in action, right? So what you're looking at is we're constructing a digital twin of a DC motor. This is actually being built using physical components. So you're putting down these components that have these physical equations. It's generating what's known as a differential algebraic equation that is all the physics involved in the object. And what's happening here, though, is someone who might not know as much about how the inertial elements work, how maybe the resistor or the inductor, you can piece together these models that someone else has already built. You just say, hey, connect these. This resistor goes to this inductor goes here. And what you're doing is you are working at a coding interface or at a GUI interface, right? You're putting in these values and you're saying, hey, this is my friction coefficient, but it's actually building a code under the hood. And it's actually bidirectional. If you modify the code, it actually will modify the GUI as well, right? And now what this is actually running now is it's now going to do a PID Autotuning analysis. So doing this kind of controls analysis on the model that we've created. Now, the cool thing about this is that these analyses, right, the fact that, oh, hey, it's able to do this noise sensitivity analysis and all this is done with an interface to Julia code. And so every one of you out there that has a Julia package, if you want to be able to put your special, your special things that you do, your surrogate generator, your digital twin pieces, if you want to make those work with the Dyad GUI, there's a direct interface, so that way we basically just say, here's how you expose your code, so that way any possible analysis can be done with the model. We're also then putting this together with automated code generation, so that way the devices that we build and tune through Dyad can actually be put directly onto airplanes, cars, and be able to be the thing that is running the future. And so that is what we're really piecing together, something that is a graphical coding environment, or a graphical modeling environment with a coding interface, tying this together with all the tooling of scientific machine learning to help improve the models that are generated, but also the generative AI tooling, so that way all of the code in the back end can be improved and the scale is run. And so basically this, it's not about just being able to build a digital twin, it's about being able to have a system where digital twins can continually start to improve themselves. And you start to have this run on a cloud system, the data's coming in, and the digital twin is just improving, and becoming more and more real because it is actually out there and living in the environment. And here's, for example, an HL-20 lifting system, which is a model of one of the older spacecraft that, of NASA. And you can see that this GUI is able to, build out these large-scale models of, of these pieces. But then we can expose, these gigantic models of realistic systems as just a component. And you start to drag them in there, and we start to say, okay, here's a realistic battery, here's a realistic car. Piece it all together, and now what is the mileage that my Tesla will get 10 years from now after the battery's degraded? And these are the questions we can start to answer and be able to know, are we designing our vehicles appropriately? So, and we're integrating this directly with a lot of the tooling that, this is really kind of changing the world, right? So here, this is a cursor integration that is working directly on the Dyad code. You can see that it is figuring out with this model, which is a model of an active suspension, how to be able to do the PID Autotuning. It's understanding and giving out information about, how this controller should work. And it actually has made a change to the code to be able to put a controller piece in there, and then it's going to run a transient analysis to be able to tell you, oh, this is actually the optimal control signal for this for the force on the seat, right? Because the idea here is, could we have components where the code is actually improving, right? So you build a car once, but if the car is actually half software, can we make it so that way you can make a simple car, a cheap car, but because of software, it's actually more luxury than the most expensive vehicle you could build? Could a software update take a $10,000 vehicle and make it feel like a Porsche? I think that this is possible, and that's the future that I think that we can all head towards. And this is what we're enabling through Dyad. There's, basically a lot of things that are going on related to scientific machine learning, differential equations, and all the things involved with modeling toolkit, aerial vehicles. These are all going as part of this push for Dyad to really pull the Julia community from things that we're doing in academic space to the thing that is now running the next airplane and the things that are running the next automotive. So thank you, everyone. So thank you very much.